Hi guys, welcome to NTI day 33. I know that says 32. We're in quarantine. Everybody's losing track of days. Sorry. So this is NTI day 33. And today we're going to be carrying on with our statistics and we're going to be talking about a box plot. And so the first thing that we need to talk about is what a box plot is. A box plot is a graphical display that highlights the lower extreme, the lower quartile, the median, the upper quartile, and the upper extreme. So we talked about yesterday when we learned interquartile range, we talked about the lower quartile and the upper quartile. And today we're just going to put the lower quartile, the upper quartile, the median, and then our lower extreme and our upper extreme on a box plot. Now, the lower extreme and the upper extreme are new words, but they're not new things that we found. The lower extreme is the minimum. The upper extreme is the maximum. Okay. The lower quartile we talked about yesterday. It's the median of the lower half. And today we'll learn that it represents the 25th percentile of data. Our median is the middle number in a data set. And the middle number represents the 50th percentile. Okay. Our upper quartile is the median of the upper half. And it represents the 75th percentile on a piece of data. So if we look, this is what a box plot looks like. Okay. It's a box and it's got these lines that extend out from it. And each line segment on a box plot represents a different piece of data. So the first line or the first dot to the furthest to the left, that's our lower extreme, which is just the minimum or the smallest number in a piece of data. Okay. The first line on our box, that represents our lower quartile. Okay. That's where your lower quartile will be at in your data set. The line in the middle of the box, that is our median. Okay, so that's easy to remember. If it's in the middle of the box, that's our median, middle number in our piece of data. The end of our box to the right represents our upper quartile. Okay, and then the furthest line is our upper extreme or our maximum. Okay, or the biggest number in our data set. So the reason that we create box plots, when I pull up Y'all's Infinite Campus, it has a box plot for every single person. It shows you like where you fall out in a whole piece of data, in a whole set. Okay, so like for example, if we look at this box plot here, if let's say this represented test averages and I got an 85, I know that I fall right here in the whole piece of data, which we use to represent percentiles. So it's important to know what each piece of our box plot represents percentage-wise. Now, we're breaking our data set into 4 sections. So each section is worth 25%. Okay, so from our lower extreme to our lower quartile is 25%. From our lower quartile to our median is 25%. From our median to our upper extreme is 25%, or our upper quartile is 25%. And then from our upper quartile to our upper extreme is another 25%. So when we look here, since this is 25%, our lower quartile is the 25th percentile. Okay. When we get to our median, then there are 2 sections below it. So that's our 50th percentile. Okay. When we get to our upper quartile, which is here, there are 3 sections below. So that's the 75th percentile. Okay. And if we scored the upper extreme, 100%, there are 4 sections below. 1, 2, 3, 4. So that's your 100th percentile. Okay, so each section is worth a 25% of the data. Okay, all right, so let's take a look at questions 1, 2, and 3. Sorry, just 1 and 2 for this box plot. On our box plot here, it says that these are representing Angela's math grades. And the first thing says, what was her median score. Okay, so if we're looking at our box plot, we remember that the median is represented by the middle line in the middle of the box. So if we look, the middle line in her box is right here. Okay, so that tells us that 75 was her median score. Okay, and our next question says, what is the range of her data set of Angela's score? So we need to know two things to calculate her range. We need to know the maximum minus the minimum. So looking at our box plot, we know that upper extremes and lower extreme mean maximum and minimum. So the maximum here is this furthest line at 100, and the minimum is our furthest line to the left, and that's at a 55. So to calculate our range, we take our maximum, which is 100, minus our minimum, which was a 55, and we get that the range of her scores is 45. Okay, all right. Next questions, 3 and 4. 3 and 4 deal with the average weight of a ninth grader's box plot here. So it says, what weight represents the 25th percentile of a ninth grader's weight? Now we know that each section of a box plot is worth 25%. So the 25th percentile would just be one section into the box plot. So if we're looking at one section in, that would be right here, halfway between 140 and 150. Halfway between 140 and 150 would mean that the 25th percentile is represented by 145. Okay. Question 4 asks, what is the interquartile range? So we have to think, what do we have to subtract to get our interquartile range? We learned yesterday to find interquartile range, we subtract the upper quartile minus the lower quartile. On our box plot, the upper quartile is our line to the right on the box, and our lower quartile is the line to the left on the box. So if we look, our upper quartile would be about right here in the middle of 160 and 170. And then our lower quartile would be in the middle of 145 and 150. So our upper quartile looks to be about 165. Our lower quartile looks to be about 145. So when we subtract those two, we get that the interquartile range is 20. Okay. All right. So now we're going to go from looking at box plots to actually creating them ourselves. So some steps for creating box plots. The first thing you need to do is find the median. Okay. Since we need the lower quartile, the upper quartile, and the extremes, that's where we're going to start. And we know how to do that because we did that yesterday. So we find the median, lower quartile, find the upper quartile, and then we're going to circle our extremes. And then it says to plot the numbers that we found on a number line. Okay. Then we're going to construct, which is just a word for make a box around the upper quartile, the median, and the lower quartile, and extend lines out to our lower and our upper extremes. Okay, so this is going to look really super similar to what we did yesterday, except instead of just leave the numbers as is, we're going to put them on a number line and make a box around them. Okay, so question number 5 here. Question 5 gives us the data set, and we have to make a box plot and then pick which box plot matches ours. So it says the following days shows the high temperatures in degrees Fahrenheit for the first 7 days in January for Mountain Resort. Make a box plot for the data set. So first thing that we're going to do is to find the median. So we're going to have to order them from least to greatest. It doesn't say that, but we know to find the median, we have to order them from least to greatest. So it looks like the coldest day here was our 17 degrees. So we have 17, 18, 19. Then we have a 22. We have a 24. a 28, and a 29. Okay. All right, so all the same steps as yesterday. Find our median. And cross out each end until we have one left in the middle. So here's our median. Okay, now we need our lower half and our upper half. So the median of our lower half, or our lower quartile, is 18. And while I'm down here, I'm going to circle my lower extreme. My lower extreme is 17, sorry. Okay, now let's take a look at our upper half. On our upper half here, we have the median of our upper half, or our upper quartile, is 28. And my upper extreme, or my maximum, is 29. So those are all steps that we learned yesterday. Today what we're going to do is we're actually going to put those on our box plot. So the first thing that we need is a number line, because we have to plot these numbers on a number line. And our skip count for our number line, I'm just going to look at the answer choices that they give us. All of the answer choices that they give us looks like they just have, they're skip counted by 2s, but they're actually put on there by 1s from 16 to 30. So I'm going to start here with 16, 17, here's 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and then 30. Okay, so I like to match my skip count to the answer choices just so my box plot looks very similar to what they have. So your number line should look like mine. And then all we're going to do is we're going to plot our points that we found in our data set. So my lower extreme is a 17. My lower quartile is an 18. My median is a 22. My upper quartile is a 28. And my upper extreme is a 29. Okay. Now it says that we're going to extend, or we're going to construct our box around the upper quartile, the median, and the lower extreme. So here's my lower quartile. Here's my upper quartile. I'm going to draw my box, and the median obviously falls in the middle. Then I'm going to draw a line in my median to show that it's the middle 50% of the data. And then our last step is just to extend the lines to the upper and lower extremes. So here's my lower extreme, here's my upper extreme, and there's our box plot. So now when we look at our answer choices and see which one matches, we're looking for a box plot that has a lower quartile, or sorry, a lower extreme of 17. And if we look, A does not have that. However, all the other ones do. Okay, we're looking for a lower quartile of 18, which all of our box plots have a lower quartile of 18. We're looking for a median for 22. C does not have that. We're looking for an upper quartile of 28. Both B and D do. And a upper extreme of 29. And if you'll see, B is the only one that has all of those things. So our answer, our box plot that matches our box plot, is B. All right, guys, so make sure that you have all of your work on your paper. Take a good, clear picture to submit to your Google form, and send us any questions that you have over email. Have a great day.